This is an entry-level maths Olympiad problem which might seem difficult, but actually it is easy. A 6-digit number abcdef is such that 6 times of it is equals to def abc. Find the value of a plus b plus c plus d plus e plus f. Now, to solve this question, we need one concept from number theory, and that concept is, whenever we say, let us take a 2-digit number ab, and if we say ab is a number, we mean to say that a and b are digits. And if a and b are digit, it means that these variable a and b should belong to this set 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, the set of these 10 symbols. Now, for example, let us assume that a is equals to 3 and b is equals to 4. Then the number formed ab would be 3, 4. And now, after this, we have a concept of value of a number. The value of a number is nothing but these variables multiplied appropriately by its place value. Since b is sitting as unit place, a is sitting at tens place, a should be multiplied by 10, b should be multiplied by 1. To verify that, let us take 3, 4. This number 3, 4 could also be written as 10 to the power 1 times of 3 plus 10 to the power 0 1 times of this digit 4. So it actually adds up to 30 plus 4, and that is actually 34. Similarly, we can extend this concept to a number having more than 2 digits. So for example, if abc is a 3-digit number, we can write abc as 10 square a plus 10 to the power 1b plus 10 to the power 0c, which actually means that, which is actually 100 times a plus 10 times of b plus 1 times of c. It is because c is at unit place, the place value of b is 10, while the place value of a is 100. Now, after understanding this concept, we are good to solve this question. So, according to the question, we have 6 times of a, b, c, d, e, f is equal to d, e, f, a, b, c. So now we'll expand these number in the same way we have seen in the previous concept. So it will become 6 into 10 to the power 5 times of a plus 10 power 4b plus 10 cube c plus 10 square d plus 10 power 1 e plus 10 power 0 f would be equal to 10 power 5 times d plus 10 power 4 e plus 10 cube f plus 10 square a plus 10 b plus 10 c. Now what actually we'll do in the next step is we'll try to take some terms on the left hand, some variables on the left hand side of the equation, while keep the remaining variables on the right hand side of the equation. So what basically I chose is to bring all the a, b and c to keep on the left hand side of the equation and d, e, f on the right hand side of the equation. So we'll get 6 into 10 to the power 5a minus 10 square a. This 10 square a comes from the right hand side, as you can already see. The variable containing b will happen to be 6 into 10 power 4b minus 10 power 1b. This 10 power 1b comes from the right hand side of the equation in the previous step. This 6 into 10 to the power 3c minus 10 to the power 0c will come from the right hand side. And we are done. All the a, b, c are on the left hand side of the equation. On the right hand side of the equation, we'll get 10 power 5d minus 6 into 10 square d. This 6 into 10 square d comes from the left hand side of the equation. The variable containing e will be like 10 power 4 e minus 6 into 10 power 1 e. 6 into 10 power 1 e. Okay. Then the variable f would be like 10 cube f minus 10 power 0 into f. Okay, this 10 power 0 into 6 into 10 power 0 into f, this 6 into 10 power 0 into f will come from the left hand side of the equation. Okay, now the next step we'll try to do is take the common numbers out, like common variables out. We can already see that we can easily see that 10 square a could be taken common from the first two term of the left hand side of the equation, and the remaining number would be 6 into 10 cube minus 1. If we try to take variable b common, we'll get 10b common, and again 6 into 10 cube minus 1 will be the numerical value left. From the variable c, only c will get factored out. The remaining number would be 6 into 10 cube minus 1 again. On the right hand side of the equation, we can take 10 square b common outside, and we would be left with 10 square d common, and we would be left with 10 cube minus 6. Okay, in the variable e we could take common 10e common. The remaining term would be 10 cube minus 6 Actually it would be 6, and in the variable f we could take common 10. Only f would be taken common. We'll again remain with 10 cube minus 6, so I'll make it 6 here also. Okay, now as we can already see, we can easily see that these variables 6 into 10 cubes minus 1 is common in each of the term. We can take it factor out and it will become 5999, and the remaining terms will write it as 10 square a plus 10b plus c. In the right hand side we can see that this 10 cube minus 6 is getting common from all these three terms, which happens to be 994, and the remaining term would be 10 square d minus plus 10e plus f. Okay, now just by checking the divisibility, we found out that this 5999 and 994 has a common factor as 7, so we'll cancel it out. It will become 857 times 100a plus 10b plus c, and 142 times 10d plus e plus f. Now again we'll have to see one fact, that this 857 could be written as 100 into 8 plus 10 into 5 plus 7. Which means which could be again compared from the right hand side as 100d plus 10e plus f. So actually we cannot compare 857 with 142, so we'll compare 857 with 100d plus 10e plus f, and 142 with 100a plus 10b plus c. So it will happen to be 857 as 100d plus 10e plus f, and 142 will happen to be same as 100a plus 10b plus c. So from these we can compare the variables, that d would be 8, e would be 5, f would be 7, and also a would be 1, b would be 4, and c would be 2. And after this we can easily find the solution that a plus b plus c plus d plus e plus f would be 27. We can add these 8 plus 5 plus 7 plus 1 plus 4 plus 2, and we'll get it as 27 as an answer. And finally this question is solved.